Assalamualaikum and hi everyone. My name is Nur Aklima binti Abdurrani. I'm from class 134.
Assalamualaikum. My name is Alia Bahira binti Izani from class 134.
My name is Nur Ain Sofia binti Muhammad Khairi. I'm from 134.
Assalamualaikum and hi everyone. Today we want to discuss about conics. This topic includes introduction to conics, how to apply the formula of conics, and its application in real life. So, let us discuss together, do our best to learn as much as we can, and respect and support each other through all the challenges. Let's do this! We start with introduction to conics. Conics or conic sections were studied by Greek mathematicians with Apollonius of Pythagoras' work on their properties around 200 before Christ. Conic sections are planes, cut at varied angles from a cone. The shapes vary according to the angle at which it is cut from the cone. As they are cut from cones, they are called conics. Further, they have some common properties as they all belong to cones. These curved sections are related too. So, basically, conics is the study of the curves of ellipse, parabola, and hyperbola. In order to understand how this curve is related to the double-snap cone, we need to first identify a few basic features on the double-snap cone. So, looking at the picture, there are three main components that are axis, vertex, and the generator. Axis is just the reference where the generator will be rotating about. Vertex is the point of intersection between the axis and the generator. It is also the tip of the cones. And lastly, the generator is a line that is used to generate the cone. The double-snap cones are generated by rotating the generator around the axis and with only one point of intersection, which is the vertex. In this topic, we study the conic section, literally sections of cones. Imagine a double snap cones as seen here being sliced by a plane. If we slice the cone with a horizontal plane, the resulting curve is a circle. Next, when we tilting the plane ever so slightly, it can produce the ellipse. Then, if the plane cuts parallel to the cone, we get parabola. Other than that, if we slice the cone with a vertical plane, we get a hyperbola. If the slicing plane contains the vertex of the cone, we get the so-called degenerate conics. That is a point, a line, or two intersecting lines. To summarize about the introduction to conics, we can see that conics section is a curve obtained by the intersection of the surface of a cone with a plane. Thus, by cutting and taking different slices or planes at different angles to the edge of a cone, we can create a circle, an ellipse, a parabola, or a hyperbola. We move to the general equation. General equation for all conics is with Cartesian coordinates x and y and has x squared and y squared as the section is curved. Further, xy and factors for this are a constant is in bold. Thus, the general equation for a conic is ax squared plus by squared plus cx plus dy plus f is equal to 0. And here is how they are different. For ellipse, both are A and B are both positive or both negative. While for hyperbola, one of A or B is positive and the other is negative. And for parabola, A or B is equal to 0. This is the equation that we can use to solve the question involving conic. While in real life, conics have many applications such in our nature and also our daily life.
Now let's take a look at the formulas and how we can apply the formulas introduced to us in the chapter Conics. First, we are introduced to the formula of a circle, given here as bracket x minus h n bracket squared plus bracket y minus k n bracket squared equals to r squared, where h and k are the center coordinates, where h is the x coordinate and k is the y coordinate, and r is the radius. We're also introduced to the formula of ellipse, where we will have two different types, one elongated on the x-axis and the other elongated on the y-axis. In this formula, h and k also represent the center coordinates. A represents the distance between the center and the major axis, the vertex on the major axis. B represents the difference between the center and the minor the distance between the center and the minor axis, and C represents the distance between the center and the foci. We are also introduced to the parabola equations, which differ very slightly from one another and are quite similar at the same time. The formulas will differ depending on the shape of the parabola. So let's take a look at a question and see how we can apply the formulas that have been introduced to us. So the question reads, show that the equation 16x squared plus 4y squared minus 64x minus 40y plus 100 equals to 0 represents an ellipse. Find the center, foci, and vertices of the ellipse. So first we take the given formula introduced in the question and apply the completing the square method. After we have done so, we will obtain a formula that we can compare with the formula of an ellipse. So from there, we can obtain the center coordinates, and seeing from the equation that we obtained from the completing the square method, we can see that the denominator of the y part of the equation is bigger than the denominator on the x part. So from here, we can conclude that the major axis is on the y-axis. So from comparing the equation that we've obtained from our calculation, we can obtain that the center coordinate is at 2, 5, and we can obtain values B, A, and C to find the foci and the vertices. So we can do our calculation, and the values are as shown.
We will continue our discussion about the application of conics in real life. Conics appear everywhere in the world and can be man-made or natural. The application of conics can be seen every day all around us. Conics are everywhere and have also helped mankind. They are found in architecture, physics, astronomy, and navigation. Bridges, buildings, and states use conics as support system, and conics are also used to describe the orbits of planets, moons, and satellites in our universe. Circles are used in real-life situations as wheels on cars, bikes, and other forms of transportation. The shape of a circle helps create a smooth movement for a car or a bike to move from place to place. Car tires are a good example of a circular conic section because they have to be exactly round or the car will not run correctly. The tires and wheels when circle is useful and important because without that, car rides will be very bumpy and uncomfortable. The ball of American football is a ellipse because this way it is easy to throw it around because it is more aerodynamic and easier to grab. It also can rotate and move quicker. This makes it easier and much more convenient when throwing the ball long distance. The shape also allows for a player to grip the ball with one hand and throw a perfect spiral, reducing drag on the football. For medical purpose, property of ellipse to reflect sound and light is used in pulverizing kidney stones. Real-life example of a parabola is satellite as the form of a parabola is satellite works to send a higher and wider signal or if it's receiving to collect better signal. The satellite have a higher directivity. Parabolic dishes provide the best optical performance because they do not bear cosine losses. Other than that, there are parabolic mirrors which use to converge light beams at the focus of the parabola, and parabolic microphones that perform a similar function with sound waves. Hyperbolic cooling towers have become the design standard for all natural draft cooling towers because of their structural strength and minimum usage of material. The hyperbolic shape also aids in accelerating the upward convective airflow, improving cooling efficiency. That's all for the application of conics in real life. Thank you.